what we're looking at here, and what Chris is going to actually demonstrate working, because it actually is working right now, keep our fingers crossed. This machine here, known as the Harwell Dekatron, also known as the Witch, and I'll explain why it's also known as the Witch in a bit. Harwell Dekatron is the world's oldest original working computer. Okay, Colossus was a rebuild. This particular machine is by some 10 years the world's oldest working machine. Yeah? Original machine. The Harwell part of the name is it was designed in 1949, went live in 1951 at the Atomic Research Establishment at Harwell. And it was built for Harwell to help design Britain's first nuclear reactor. Essentially it replaced a load of human beings it replaced a load of human beings using these hand-cranked mechanical calculators. Not because they was too slow, but because human beings make mistakes. And they were doing some pretty fierce calculations and having to double check the results, triple check the results, and so on. And it really was going too slowly. So this machine was built to handle the calculations. It was built for reliability, and it was built, Chris will explain how fast it is. It was built to run for days on end. Yeah? The Dekatron part of the name is because it uses the Dekatron tube. Yeah, unlike the valves on Colossus, two things about them. One, they're thermionic, they're hot. Yeah? They've got filaments in them. And two, they're binary. A Colossus valve is on or it's off. Yeah? Essentially binary. The Dekatron tube is a very different thing indeed. Firstly, I can hold it, and I'm not sizzling. Yeah? Do you want to touch it? Yeah, it's actually not even warm, is it? Yeah. Very green, these. We'll come back to that. Use very little power. But the crucial difference is, you see the light going around, yeah? If I press the stop button, it stops in a position. That's number 9. Yeah? If I press it again, that's a 6. Yeah? You could actually, there's 10 stop positions on here. So you represent the values 0 to 9 on a single tube. Makes this a decimal machine. Okay? There were a few of them around at this time. It didn't last, everything went binary again. But, okay. Do you want to explain, storage aspects?
Essentially it's a method of storage. If I can represent the digit 0 to 9 and I can work out a method of reading it, then we've got ourselves storage. So we're going from Colossus that has no RAM, essentially, to organising a machine with 90 rows of Dekatrons and hence 90 stores. Each one of these can store a value. We use the first Dekatron to indicate the sign, plus or minus, and then this is, for example, 6, 0, 4, 8, 7, and so on. And therefore we've got the ability as part of our calculation to store numbers, and more importantly, we can read in instructions from paper tape, or orders as they called them then, and store instructions in memory. We've got the concept of the stored program. So what the machine's doing at the moment is it's read instructions off of paper tape, which is similar to the tape that Colossus uses. It's 5-channel, and we've not got as far as ASCII yet. And it's read the instructions in, it's stored the program into an area of memory up here, and you can see it fetching that instruction. When the Dekatron spins, it's being fetched into the logic and obeyed. It will carry on up through and round and start again. At the moment it's doing not a terribly difficult task. It's working out what once one is, 2 2s, 3 3s, 4 4s, up to 99 99s. It's testing itself as it's going in a loop. When it gets to 99 it will stop gracefully. Each time it goes through a cycle it's printing out the results on a 1940s printer, actually older than the Harwell Dekatron computer itself. Devil's own job getting the ribbons for that, but it is a working machine. So here you have the accumulator. Up here the pulse generator, which is like a clock synchronising the whole machine. Translator, converting any orders stored in memory back into the logic which is behind these cans. We have post office telephone relays offering us the method of developing logic. They're behind the cans to limit noise and stop dust getting inside. Control panel telling us at what location, for example, it's doing location 46, that's the instruction that's being obeyed, and various other controls, power supply, and then multiple paper tape readers. One you might put your program in, the next you might put in data for your program, and then they got really clever with the third one because they used to stick the two ends together, put it in, and of course that's a subroutine because it would go round and round every time you wanted it to. So they're quite adventurous in their use of this machine. Not terribly fast. If you wanted to do, for example, 100,000 multiplications, which in today's terms wouldn't be a great deal, then you'd have to go away and come back in 17 days' time for the answer, but it would be right.
Just to complete its history, Harwell had finished with it by 1956, but instead of scrapping it, which is what happened to virtually every other machine of this era, instead of scrapping it, they got a bit more creative. They ran a competition amongst academic institutions to see who could make the best use of it for teaching computer science. A college in Wolverhampton won it, the Wolverhampton and Staffordshire College of Technology, now Wolverhampton University. They took it over in 1957 and used it till 1973. Okay? They were the people that renamed it the Witch, okay, and put this plaque on it. Wolverhampton Instrument for Teaching Computation from Harwell. Which, very easy to say. They added these drums up here, and if you look really closely, you probably can't see it in this light, there's CRLFSP, using the little jack plugs, line feed, carriage return space, actually for formatting text on the printers. Very early form of print control. Yeah? Okay. 1973 it goes to Birmingham Museum of Science and Industry. Static display till the museum closes till 1997, into storage, rescued by one of our trustees about 3.5–4 years ago, came here in pieces. We've been working on it on and off ever since. We announced it to the world that this thing is reborn last Tuesday, a week on Tuesday.